Hello viewers, in this video we will see the solution to week 9 assignment 9 for the course analog communication. The solutions are our suggestions. First question, for a random process characterized by additive white Gaussian noise, which of the following statements accurately describes its autocorrelation function? The answer is option A, it is a Dirac delta function. Second question, assuming perfect recovery of the carrier component is possible for both SSB, SSC and DSP, SSC signals, which of the following statements about their figure of merit is correct? The answer for this is option C, the figure of merit for SSB, SSC and double subband suppressed carrier are equal. Option C. Third one, an additive white Gaussian noise contaminated signal is passed through a filter of bandwidth 100 MHz. If the noise power in the filtered output is 10 nanowatts, then the value of one-sided noise spectral density N0 is, answer is option B, 10 power minus 16 watts per hertz. Option B. Fourth question, in a receiver, the power of an input signal is 200 microwatts, while the power of the additive noise is 20 microwatts. This noise contaminated signal is passed through an amplifier with the power amplification factor 10. However, the amplifier also adds noise to the amplified signal of power 50 microwatts. The signal power to noise power ratio of the final signal is, the answer is option 8, option B 8. The thing is, here the signal power is amplified by 10 times, it becomes 2000 microwatts. Noise power also becomes multiplied by 10, it becomes 200 microwatts. 200 microwatts plus 50 becomes 250. The ratio of 2000 divided by 250 will be 8. Okay. Next, consider fifth question. Consider a bandpass noise defined by alpha NIT cos omega ct, beta NQT sin omega ct, and they have given NIT and NQT are independent based on the processes, independent baseband processes, each with the power p. Determine the power of n of t. So the answer for this is option C. Option C. P into alpha square plus beta square by 4. Sixth one, a certain communication channel has a transfer function HC omega equal to 10 power minus 2 over the signal band. The message power spectral density is gamma pi omega by delta. The channel noise power spectral density is 10 power minus 2, 10 power minus 8. If the output SNR at the receiver is required to be at least 20 dB, what is the value of gamma corresponding to the required minimum transmitted power? So the answer for this question is option B, 0.01. Seventh one, in the question above, suppose the separate transfer function of channel function is changed to 10 power minus 3 j omega plus alpha, then noise pulse percent is 10 power minus 10. To compensate for the channel distortion, the receiver filter transfer function is chosen to be HD omega equal to j omega plus alpha by alpha pi omega by 2 alpha. The receiver output SNR is required to be at least 35 dB. Determine the minimum value of minimum required value of beta. In this question they have not given beta here. The parameter beta is not mentioned. So therefore we can choose any answer. We can choose any option. So I am choosing option B. Option B. Eighth question, in a double sideband suppressed carrier modulation system, if the carrier frequency is changed while keeping the message bandwidth and the average power constant, average signal power constant, how does this affect the output signal to noise ratio at the receiver? So the answer is the SNR remains unchanged with the change in the carrier frequency. Then comes uh, ninth question, an unmodulated carrier amplitude AC and an unmodulated carrier of amplitude AC and the frequency FC is added to the band limited white noise and passed through an ideal envelope detector without a DC blocker. Uh, Assume the noise pass frequency to be of height N0 by 2 and the bandwidth through W centered about the carrier frequency. The output signal to noise ratio for the case when the carrier to noise ratio is high is the answer is option C. Answer is option C. AC square 2 N0 W. Last question. Consider a double 7 suppressed carrier coherent demodulator whose local oscillator suffers from a phase error theta. If M of t is a signal of bandwidth B with the power P and the channel noise power intensity N0 by 2, the output SNR is option C. Option C, P cos square theta 2 N0 B. Thank you, viewers.